Simultaneous equations. Great. Right, here's the first step that a lot of people make, and they lose all of the marks available, which is often 5 or sometimes 6 marks for a question like this. So here's what not to do first. Why is that wrong? Well, first, what have they tried to do? Well, they've gone, well, this first equation's got x squared and y squared in, so wouldn't it be good if this equation had x squared and y squared in as well? So let's just square the x, square the 2y, and square the minus 3. So we get x squared, 2y all squared, 4y squared, and minus 3 squared. Well, there's two things wrong with this. For a start, minus 3 squared is plus 9. But in any case, you cannot square separate terms in an equation. You just can't do that. You can square entire sides of equations, like this. You can't square separate terms in an equation. If you could, then you could also square root separate terms of an equation, and Pythagoras' theorem would therefore simplify to a plus b equals c, and we know that that's not possible. So we know we can't square root separate terms in an equation, and believe you me, you cannot square separate terms in an equation. So you can only square whole sides of equations. So first use this equation and square it to get an expression for x squared. I'm going to substitute that into the first equation. So 2 lots of x squared plus 3y squared equals 14. And now we need to expand, but we need to be really careful with the expansion. So over here, out the way, I'm just going to work out what is 2y minus 3 times 2y minus 3. Okay, and I've done that out of the main stream of working, and I'm now going to feed this result back in over here. So 2 lots of all of that plus 3y squared equals 14. I can now expand to do 2 times each of these things in this bracket, and then collect like terms and simplify, and we get down to this nice quadratic expression in y, although not particularly nice. Now if you have a ClassWiz Casio calculator, you can now solve this for y using the solve function, which you need to know how to use before you go into your exam. If you want to do it by hand, then again we're going to have to come out over here out the way and just work out how to factorise that expression here. Well, 11y squared minus 24y plus 4. Note down what AC and what B is. So AC is 11 times 4, and B is just the number of y. I'm looking for 2 numbers that times to give 44 and add to give minus 24. And after a short search, you'll find that those are minus 22 and minus 2. And then the quick shortcut method here is to simply write, so take this number here, 11, and go 11y minus 22 and 11y minus 2, and divide each of those brackets by its highest common factor, which in the first case is 11, and the second case, it's pointless dividing because it's just 1. But altogether we should have divided by 11, and we have, so we end up with y minus 2 and 11y minus 2. Substituting those, or bringing that result back in over here, and then writing down the y values, which should be 2 and 2/11, allows us to almost finish this problem. We need to know the x values as well. Look, we have a handy formula for x in terms of y. So substitute your y values into this to get x, and we get those. Now, don't leave your answer like that, because you need to group together your x and y in correct pairs. It's no good having this value of y and this value of x. So a crude way of doing that is to just circle them. But a better way is to write them out as coordinate pairs, the way we'd normally expect x and y values to be paired up.